Linear graphs, parallel and perpendicular lines. Now if you have one equation with y equal to, the gradient is m1, then it's times x, then plus c1, then we have another equation, y equal to m2 is the gradient, then c2 is the intercept. When we're talking about parallel and perpendicular lines, so the intercept do not play any role at all. So we're only interested in the gradients. So if the two lines are parallel, then the gradient here m1 must be equal to the gradient m2. If the lines are perpendicular, then the product of those two gradients is equal to minus 1. So m1 times m2 is equal to minus 1. Now this equation would help you if you know one gradient, say you know m1, you want to find the other gradient, perpendicular gradient, so just divide both sides by m1, so it's minus 1 minus 1 divided by m1 on the bottom. Now we do these examples. So A, so comparing to y equal to mx plus c, so we have minus 2x plus 3. So therefore the gradient m is just equal to minus 2. B, the equation 2x minus 5y plus 1 equal to 0. So we have to make y the subject. Take y to the other side, so it's 5y. Then we left here with 2x plus 1. Now you need to divide every term by 5. So we get y equal to 2/5 x plus 1 over 5. Now we're comparing this equation to the standard one. So the gradient is the number before x. So therefore m is equal to 2 divided by 5. Now C are the lines, we want the gradient of the line which is perpendicular to this. So this equation in standard form, so therefore the gradient is equal to 3. Then the required gradient so we use that equation m2 is equal to minus 1 over m1. So therefore, the gradient we need is minus 1 over 3. Then D, x plus 2y minus 3 equal to 0. First we need to make y the subject, so we take this and this to the other side. So 2y is equal to minus x plus 3. Now we can divide every term by 2, so y equal to minus half x plus 3 over 2. So therefore, So the gradient here is minus half. So the required gradient m2 is equal to minus 1 divided by m1. So you have to divide by minus half, and this is equal to 2. Now we do example 2. So part A, so the line is parallel to this, so therefore the gradient we need is equal to 4. So it's going to be y equal to 4x plus c. We don't know the c. We can find c by substituting these two numbers for x and y. So x is 1, so therefore 4x, 4 times 1 plus c, so y is 7, so therefore c is equal to 3. So the equation is y equal to 4x plus 3. Then b, so we have the equation y equal to minus x plus 6. So m1 is equal to minus 1. So the gradient we need will be minus 1 divided by minus 1, which is just 1. So the equation is y equal to 1x plus c. Now we substitute these two numbers. So x is minus 4 plus c equal to y, which is 3. So from here we get c equal to 7. So therefore the equation is x plus 7 c, so x minus 3y equal to 0. So it's 3y equal to x. So y is equal to 1/3 x. So the gradient m1 is 1/3. So the gradient we need will be minus 1 divided by 1/3, which is equal to minus 3. So the equation is minus 3 y equal to minus 3x plus c. Then we substitute these two numbers, minus 2 minus 2, so minus 2, so this is plus 6 plus c. So from this equation we get c equal to minus 8. So therefore the equation is minus 3x, then s minus 8.